All right. So today we're going to talk for a little while, just talking about testing, what it is, why we do it. There are some different kinds of tests, unit tests, integration tests, and end-to-end tests. And we'll talk about what each of those tests is and what the trade-offs are. What kind of things to write tests for, uh, some pros and cons of tests and test-driven development. Then we'll take a quick preview of different testing frameworks for the front end for React. And we'll take a preview looking a bit further ahead at the testing library we'll use with Django when we circle back to the back end on Python. And then we'll spend some time digging into Cypress. And Cypress is the test suite that we'll be using with React. Just like with the OOP assessment, the React assessment will have a Cypress test suite. So this will be really valuable and critical for the assessment is to be comfortable with Cypress. We'll see how to set up a little bit of configuration. We'll write a Cypress test. We'll talk about it. We'll see how to run it. We'll discuss if you're on WSL2, there may be an extra step that we'll do a little, if necessary, follow up with after the lecture. And there's a little bit of an asterisk if you're on Linux as well with Cypress that I'll point out. And then if we have time, we'll write a bit more React code and maybe write a test for it. But that's really depending on time. Really, the focus of today is talking a bit more about testing and introducing Cypress. So I'll just pull up what we have and I'll start to talk through it. So, there's one bit of advice that I consistently give to folks in terms of like, once you've done your personal project and you've graduated and you're continuing to write code, like, what's the best way I can do something to help, basically stand out, right, on the job market? And if someone's looking at my code base, what's something I can do that'll really help my code stand out? And there's a lot of valid answers to this question. I give one particular set of answers for a particular reason. And I say documentation, testing, logging, caching. Any one of those things, if you really go deep into it, will help you stand out. Because when you're doing software engineering as a professional task, in a professional context, in a business environment, where there are consequences. If you think about how much money Amazon would lose per second if their website went down, right? Or if you're on a team of like 7 engineers, things that aren't necessarily the most exciting or important at first glance are actually critically important for software engineering, though they're not the only thing. But understanding that can help you stand out. And so testing is one piece of a bigger picture. We've all seen some tests, right, in the unit tests for assessment 1. And also there were end-to-end tests as well, and I'll talk about that in a moment. In fact, I think it might have been mainly end-to-end tests. What is testing? Why do we do it? I would just love like maybe 1 or 2 people. What's your hot take? Why do we do testing? And if someone is like, man, I hate testing, that's a perfectly legit hot take too. But what do we think? Mickey, yes, sir.
So everything breaks in front of us instead of the user.
Yeah, that's a great example. So that why do we do testing? So that we can find out if something breaks before it goes live or deployed to what's called a production environment, as in the live website in front of the user. Exactly. Any other thoughts around why we do testing? Brandon, yes, sir.
It's almost like brainstorming potential problems that could arise in the future. So like sometimes you'll write a program with no testing and you won't even think about like what could possibly go wrong. But during testing, the whole idea is to think about what could possibly go wrong. And so you are able to find problems before they even become problems.
Yeah, I think that's a really good perspective. Writing tests forces us to think about what might go wrong, and that improves our design. And Cody, yes, sir.
Yeah, and thinking for like big picture, big companies, I imagine they probably have a testing team and then a programming team. So you have two separate teams, and then you both get the same, requirements from the project manager. The test team hopefully write tests to exactly what those specs are, and then you hopefully write code to what those specs. So it gets people more on the same page.
You actually raised a really good point. How do engineering teams and companies organize testing? And sometimes what you're describing is the case, sometimes it's not, and it doesn't always depend on the company. There are a lot of big companies out there. So what happens, first of all, is, as you all will discover with your group project, 5 is actually pretty big for a software engineering team. 7 is really big. Amazon has, I think they called it like the 1 or the 2 pizza policy. That like a software team shouldn't be so big that like 2 pizzas can't feed it. Yeah, a team can be only big enough to be fed with 2 pizzas. And it's true. Frankly, 7 is getting big for a software team. So as applications get big, you have an engineering department, but you have all these smaller teams that own different parts of it. And you might have many different applications. And so it's not uncommon for teams to own their own testing and write their own tests. Everywhere I've worked as a software engineer, I have had to write tests for every feature I wrote. Now at one company, I also had to be my own QA and manually test it. And then when it was deployed live, I had to monitor our logs to see if there were any bugs that the logs caught, and if so, fix them. And I was responsible for deploying it. At another company, we had a QA team that once I had my automated tests, they would manually click through and do stuff. But the QA team was so overloaded that developers still had to do that all themselves, so that the QA people weren't finding, it wasn't like I didn't look for the problems. It was I looked for everything I could, and then anything I didn't catch, QA got. Len, yes, sir.
So on the hot take aspect, I think that you said you did everything, and you really should try and have a independent person on the side. I always say try and have grandma do it. That's always how I look at it. Because if grandma can do it, then you know that the general public can do it when you're testing. But you both have to have an understanding of what the general testing is. I've seen it happen a lot where one person gets overloaded, and then it's like proofreading your own paper. Sometimes you miss things.
Right. And I think you're thinking more about, we would call it QA or quality assurance, where someone is actually using the application and manually testing it, as opposed to writing an automated test suite. Right. And that's actually an important point too. Like that QA process is extremely important. But when you hear people talk about testing, we're talking about writing tests, like you saw for the OOP assessment, and test frameworks and test suites. The one thing I'll say, and then we should kind of move on, is everywhere I've worked, the ethos essentially was like, if I was given a feature or a task, I owned that task and end to end. Like as an engineer, I was responsible for talking to designers. I was responsible for talking to product people. I was responsible for shepherding it through deployment and QA to make sure it got done and out the door. And I think that's pretty typical of startups. Some big companies don't work that way, some do. I think as like a philosophy, and as you think about like as a software engineer, what's my responsibility? It's a really good perspective, because it turns out it's a lot of work to get it out the door. It's just a lot of little things that have to happen. So I would encourage you all to start like thinking about that as you think about like, what's my mindset as an engineer? And so often teams write their own tests. You know, if we're Boeing and we're writing the tests for airplane software, which they do not do a great job of, it very well may be that there's a dedicated test team. And in fact, like test engineer or QA engineer are both software engineering roles, and test engineering can actually be really interesting because you might have like a whole big system that you need just set up to run a big automated test suite. So it can really depend. But for us in this class, and I think the perspective for you to have is that you're going to have the responsibility and ownership of writing the tests for your application. There's a couple other reasons to write tests, and I'll throw in, we'll talk about type of tests in just a minute, but just to share an example, what if we find out that there's a bug and we fix the bug? Well, once I've done that, what happens a lot of the time is that bug gets introduced again. Because if a bug happened in the first place and it got past code review, it means it probably was a bit tricky. And so when a bug happens for the second time, it's called a regression. And it happens way more often than you would think. And so what you do is when you fix a bug, you write a test for that bug. And that's called like a regression test. To make sure the bug doesn't happen again. And this points out another useful function of tests on teams. Tests are one form of documentation, right? So that's another reason why to write a test. Another reason to write a test is, what if I have a big code base that's old and I need to change a lot of it, but I'm worried about breaking stuff? Well, if I write what's called a test harness, where I write a bunch of tests for the application as it is, then I can safely refactor or change how the code works without changing what it does. And the tests will tell me if I do something wrong. And in fact, there's a whole book on refactoring. Eric, yes, sir.
So on the concept of that, so that means like writing a test harness that your app currently passes all tests for, and then you refactor from there to get to where you currently are with the new code.
Exactly.
Okay.
Because raise your hand if you had code that worked and you want to make it better, but along the way you introduced a bug, if that's ever happened to you in your life. Right. And everyone in the class here should be raising their hand. That's a great example of where tests can actually be your friend, right? If I write tests, it can help me, because if I make a mistake, as I inevitably will, because that is the nature of programming, the test tells me, right? So it's like a test harness. And the more you write software, the more you realize like all these workflow and processes about the fact that like programmers, we make errors, like we're human, we're fallible. So our process is designed to help us catch those errors and address them as easily and quickly as possible. All right, let's dig in a bit to different types of tests. One type of test is called a unit test. And a unit test, like a good example would be tests for a specific Python class. Right? Maybe, right, if we think about the school app, maybe there's a student class and I can write tests that test all of the methods for the student class. An integration test, a unit test tests an individual unit. An integration test tests like several classes interacting together, right? How the different parts of my program integrate. Any thoughts what an end-to-end test might be? Just kind of based on the name. Brandon, yes, sir.
And then would be like you're testing the entire functionality of your program, simulating like a user experience.
Yeah, exactly. Yeah, and you hit the nail on the head. Like, end-to-end test is, simulate the user experience and actually run the whole program end to end. Right? Excuse me. Right, and use monkey patch to simulate command line input for my Python program. So all those tests from the OOP assessment where monkey patch was doing stuff, those were end-to-end tests. And actually, this is not an example. This is more of a definition. I'm not sure of an example off the top of my head. And the definition of an end-to-end test, as you said, Brandon, is like run the program exactly how a user runs it and test it that way. Murad, yes, sir.
So what the difference between the integration and end-to-end? I feel like it's the same. Integration, we run the test over all the part of the program, right? To make sure the whole program working efficiently or working. And end-to-end, for me, it sounds the same, right? Or there is difference between both?
That's a great question. Yeah, it is a little fuzzy. And I think a good example of the difference between the two is an integration test might not be all of the different parts of my program, but just to use an example from OOP, if you think about, I think it was maybe the school class, and the school class was doing stuff with the student class or other classes. If I'm testing the school class, there are ways that I can test it to see how it's interacting with other classes. So there's ways that I can integrate some parts of my program, but not necessarily the whole thing. While so it can get a little fuzzy, but the difference is an end-to-end test is very explicitly running the program exactly the same way our user would, as much as we can, and testing it that way and doing the whole thing end to end.
Yeah, that's enough to know. Thank you.
Absolutely. Eric, yes, sir.
So to me, it would make sense that when you're doing like end-to-end testing, you would probably be running like potentially 3 different testing frameworks, right? For like the front end, you could have maybe PyTest and also Jest maybe. So I guess what is I don't know. I guess I'm just trying to picture the full testing picture, I guess.
Yeah, totally. And we haven't really think monkey patch, and when we see Cypress, I will come back to this. Because what Cypress does is it actually controls the browser. So we can write a front-end application. Cypress is actually going to control the browser and click on stuff. And then our JavaScript code will actually call whatever APIs we have it doing. If we have a backend, it'll call that backend. And then Cypress looks at the DOM to see if everything looks the same way it should, right? So it literally does what I as a user would do clicking around on my web app. And that's an end-to-end test. Erica, yes, and then we should move on.
For example, end-to-end, would that be, for example, trying to find an exploit or trying to overload the system like a user would by inputting like stuff, finding loopholes and inputting stuff that's incorrect and stuff like that?
Yeah, that's a great question. All those could be different types of end-to-end tests, yes. Whether you're like trying to stress the system or cause it to break, that the end-to-end is, those could all be end-to-end tests. You could do it with unit tests as well. The main thing with end-to-end is like it should be doing exactly what the user does, right? Because that way I figure out if there is a problem, because I can see all the pieces, like I'm actually running the program. And again, just think about monkey patch, right? From that OOP assessment, like that did the exact same thing that we would have done on the command line running those tests. Actually, as to your point, this is a little out of scope, and then we'll move on. But Netflix if you're Netflix, you have a massive cloud, you know, how do you make sure that everyone can watch and stream their Netflix at the same time when, you know, the hot new thing comes out and everyone goes online to show it? And how on earth would you ever test that? And so they came up with this thing called Chaos Monkey, and they actually run it on their real cloud, and it goes around and breaks stuff, and they see how resilient their system is. So there's, and this isn't really like a particular kind of test, but as to your point about sort of stress testing stuff, Erica, like testing actually is a really interesting area to explore, and we're just sort of scratching the surface with it. So you all have raised some really good points, what to write tests for. Edge cases, you know, such as unusual input. Erica, as you pointed out, bad user input, right? In fact, I want to explicitly test for error cases. I want to test for, let's see if I can't format this to make those squigglies go away. I should test for my success cases as well. What kind of things do I want to write tests for? You know, does a component render correctly? Does my app look correct in the browser? Has my database been correctly updated? Are the methods of a class doing what they should? Right, and I think the best way to kind of learn this is to look at other tests, and I think that's where the test suites that we do have can be really useful, and the assessments. And as we look at Cypress, we'll see all the options that it gives us. So let's talk pros and cons. We'll talk a little bit about TDD, and then let's dive into Cypress. So, anyone have a guess about maybe some pros and some cons of a unit test, an integration test, or an end-to-end or E-to-E test? Like, let's talk about unit tests and end-to-end tests, since those are sort of the extreme examples. What's a pro of an end-to-end test? Erica, yeah.
And you make the user flow much more like better just because you already tested for user case scenarios.
Yeah, I think that's more of like, yeah, I would agree with you. And I think I would rephrase that a bit just to say, like, end-to-end tests are real. Like, exactly like you're saying, like, we're actually testing the real behavior of the application, so I can get real data from it. In terms of like improving user flow, to be honest, that's not really what tests are used for, because by the time we're writing tests, like, the application has already been looked at by designers and talked about. And if the company does user research, they've done that. And product teams and designers absolutely do get user feedback. And in fact, like websites like monitor every click that you do, and product and design teams will use that data to see real user behavior and improve the UI and the user experience. But that's not primarily what tests are for. But that is a good thought, and there are a lot of other ways that that's done. You know, what you touched on is that end-to-end tests are real. So they give us the highest degree of certainty that our application is correct. And actually, if I jump back up to testing and why do we do it, I'll add one more point here. If I don't, how do I know if my program actually does what it should? How do I actually know if my program is correct or not? Right? And not just like I've written a program and I can run it and click around and see how it is. You know, like if we are Google, how do we know that our search engine is actually doing what we want it to do, that the best results are being delivered first? And there are many ways to solve that. Software quality involves code review. It involves the development process. It involves what technologies we use, but testing is one piece of that puzzle. Right? And an end-to-end test is the real thing. What might be a con of an end-to-end test? So the biggest con of end-to-end tests is they usually take more time and effort to make. And you all got a taste of this when you saw, say, like the tests with Monkey Patch versus not. As applications get more complex, it takes more effort to set up an end-to-end test. And we'll kind of see with Cypress, we need this whole other framework. They can take longer to run because we're actually running the real application, and use more computing resources, whether it's databases or cloud environments or whatever. Therefore, they cost more time and money. They're more expensive. Unit tests. Pros. Cheaper, easier to write, less resources in general to run, cost less time and money. Cons, a unit test only tests the one bit of the code we are writing the test for. My student class might work great, but my program is actually feeding bad data into it, and I wouldn't find that out. And integration tests, Mourad, as you pointed out, they're again, if you think about testing how like certain classes interact, but not necessarily everything. So integration tests are basically like pro cons are right in the middle. Right? They're not as expensive as end-to-end tests. They're not as cheap as unit tests. They give me more test coverage of my application, but not as much as a true end-to-end test. And I just want to pause and see if folks have any questions before we talk a bit about test-driven development and then kind of move forward. And do folks feel like the picture of testing is starting to be painted in terms of like the role it serves on an engineering organization and the value of it when you're building something big that has real users and real world consequences if it's not working, and how actually this can help us be more efficient and productive? And I realized that that was a little bit of a rhetorical question because I kind of answered it as I went. So hopefully the answer to that question is yes. And that leads us to test-driven development. There are a lot of different ways to write tests and testing strategies. And testing strategies are part of an overall software development strategy. Like a team's testing strategy will be part of a bigger piece because it depends on what technologies they use. It depends on their code review process. You know, if it's a small team of like 4 really experienced people, they might not need to write as many tests. If it's a team of 9 and there's a lot of junior devs, you might need more tests. So test-driven development has become a particular popular strategy and people have really strong feelings about it, but it does certain things well that do give value. And testing is always a question of trade-offs. Because at the end of the day, tests take time to write. And while they are one way of improving software quality and maintainability, and maintainability and reliability is an important feature of an application, it's not actually a feature that directly delivers value to users. So it is very much a balancing act of how much tests to write and when. But test-driven development, it's basically the idea that, you know, we've talked about this, you've heard us say this, like the big ideas are tests. Basically, tests are the best form of pseudocoding. I don't entirely agree with this. I don't even think the TDD people agree with this. So let's say tests are one good form of pseudocoding. Writing tests first forces you to think explicitly about your design, right? Inputs, outputs, methods. It forces you to think about the design before you write the code. As you write the code, the tests help keep you on track. You do less work as tests force you to think about what you need versus what you don't. And really, this isn't big ideas. This is really, I would say, like what the benefits are, right? And what it's all about. And the idea too is like improves workflow and productivity because it gives a consistent and explicit process. And the basic idea of test-driven development is red, green, refactor. First, write tests, then write code to get each test to pass one by one. Only write the absolute minimum you need to get the test to pass, then refactor your code. And as you do this, if you need more stuff, write more tests for it first. It's a very explicit process. Not everyone likes it because it does force a certain workflow. It goes through trends, but it's been popular for a while. It's still relatively popular. I think actually for junior developers, it gives a really good explicit structure. And it's sort of like a test harness, right? It gives you a system. And as you get more experience, you kind of know when to break the rules. And you've seen, I'll like run my code every 2 minutes and with console logs. That's sort of like my own version of TDD. But in part, because I've been doing that for a long time, it's easier for me to do it, but it's the same idea. So there's more to TDD than that, but this is the essence of it, and this is the value proposition. And there's a good chance that it will come up in technical interviews. So it is important to know about and file away. And it's why we have a bunch of tests on Udinit on our assessments. So I just want to pause and check in and see if folks have any questions. And then I think I have been going on for a bit, so we'll take like a short break and then we'll take a look at Cypress. So I'm curious to see if folks have any thoughts about TDD or if anything's on people's minds. Has anyone been doing test-driven development? I'm curious, like for the assignments and stuff. Yeah. I think, to be honest, that the pace we move in the course, it can be a bit challenging because we're throwing so much at you, and writing tests takes time. Believe me, software engineers have mixed feelings about tests because of how much time it takes to write them. And there's a lot to learn. I do think you've seen me make the to-do list. I do think you should think about this process, and kind of similar to TDD, there's a great book called Code Complete, and it's like this massive tomb. Like, you don't read it in one go. Like, there's a chapter on like how to name functions. And let's see if we can't find a little bit of it. I think we have it in like a link somewhere. I think we reference it, but the one bit I want to point out, and the reason I love it is software construction, designing classes, metaphor, like measure twice, cut once, and somewhere in here he talks about pseudocode. And let's see if I can find it real quick. We'll take a look. Otherwise, I'll just share it and I'll share the chapter later. But he has a whole chapter on what he calls the software construction process. And it's really an amazing book. I can't recommend this enough. So if you're interested in the process of creating software, this is the book to read. And I'll just share the link. I'll just download this and share this later and share the page. But the reason I wanted to mention it is because he talks about, like, you know, writing pseudocode. Like, you don't have to write a test. If you can express in plain English sentences what you want, like the class that you're about to write or the component you're about to write to do before you write it, that's half the battle. And I think that's the really important piece, is this idea of there's two separate stages, some designing and then some coding. And everyone comes up with, I think, a workflow that they like at the end of the day. But if you don't have those two separate stages, as the programs get bigger, you're gonna realize there's a point where you're just treading water. So I would encourage all of you to start thinking about, how do I think about what I'm gonna do and write it down before I start writing code. All right, on that note, let's take, it's 9:49. How are we feeling? Are people good with a 5-minute break? Okay. Yeah, let's take 5 and then we'll come back and we'll look at Cypress. Thank you, and see everyone in 5 minutes. All right, so we talked a lot about testing, and just to kind of reiterate and remind you all that we also have a really nice breakdown here in our curriculum doc. Unit tests focus on individual units or functions. They're fast, they can give a safety net. They might miss integration issues because they only test parts of our program in isolation. Integration tests look at how the different parts of our application work together. And Francisco, thank you for throwing into the chat, like, a great example of an integration test might be testing how my Flask code talks to Postgres, how those two parts of the system interact. But maybe that particular integration test doesn't test the front end, or testing how my Flask code talks to the Pokemon API, but that particular integration test does not test, like, the front end, the React front end. They can be slower than unit tests because it's not an end-to-end test. They might not catch all the issues. The end-to-end tests are the big kahuna. They simulate user interactions. We get very realistic results of our application. They can just be more brittle and harder to write and make them costly to maintain. We talked a lot about pros and cons, so I won't go through this. The one con I'll mention is, if the test is wrong, the test will never know. And the tests will never catch the things that we don't write tests for. And because the nature of programming is making errors, there will always be times when the test is wrong. And there will always be things that we do not test for. So tests by themselves are only one piece of the puzzle for writing quality software that is easy to maintain and is reliable. We talked about test-driven development. Now let's look at some frameworks for React for testing. And let's look at Cypress and Puppeteer. Lennon, you're saying AI will never win. Humans will always be in the loop. Yeah, we'll see. The AI is getting better. It does raise a great point, right? Because ChatGPT can write tests till the cows come home, but who watches the watchers, so to speak? Who knows that
Exactly.
ChatGPT is writing correct tests? Yeah, and there's whole fields of study, other ways of verifying programming correctness, that are not about tests and more theory based, that I don't know a lot about, that are very interesting and powerful, but also more complex. So let's take a look at Cypress, which is what we're going to be using here in this course. And as I mentioned, Cypress actually drives the browser for us. Cody, yes, sir.
Are you looking to share your screen?
Oh, I am. Thank you so much. I totally forgot to do my screen check. Thank you. Yeah, so when I was talking about the curriculum doc and this and that, I was going through it and highlighting the actual bits. So Cody, thank you so much. So just as a friendly reminder, like once you hit graduation or you're preparing for a mock interview, pull this part of the curriculum up and just kind of review this, like, overview of testing and the different kinds. Okay, and now we're looking at Cypress, and we pulled up the docs for it. And Cypress lets us write both end-to-end tests. It's actually going to move around the mouse on the browser, drive the browser for us, and we can use it to write tests of individual, usually React components, but component is also a more general term, and it can also be used for integration tests as well. And as we're learning with docs, looking over the installation steps is always good. We have this in our curriculum, and we'll go through that in just a minute. And let's take just a look at using Cypress with React. And down here under component testing, and they have, if you have, I do recommend reading a bit through these docs because they do go through it in detail. We'll cover a lot of ground. Testing strategies, this stuff is actually less useful. As you can see, this is really specific to certain technologies. Migrating from other frameworks, not relevant to us. Component testing, may be useful to look at this. Really, it's the React component testing that's going to be where the good stuff is for us. If you're curious and you want to dig more into Cypress, the core concepts area could be good. And they too have their sort of different kinds of tests 101 and how to write tests and this idea of test isolation and some important concepts. So this stuff could be good to read, but definitely here is where we want to start, right? And let's see kind of what we see here. And we're going to run Cypress in just a minute, but just to get a little bit of a preview, excuse me, let's take a look at some examples. Let me go ahead and just make this a bit bigger, and let's look at this and talk about what's happening here. So there's some React component named Stepper that's been created. And what this test is doing is testing that a component has been mounted. And can anyone remind me, what does it mean for a React component to be mounted? We've talked about this a little, but not a lot. So if someone's like, I feel like I 50% know, that's good, and you should take a crack at it. What does it mean for a component to be mounted? Brandon, yes, sir.
Is that when a component is like pre-rendered?
Close. It's when a component is attached to the DOM. And usually when a component is mounted, it gets rendered for the very first time. You could have a component be like mounted on the DOM, but maybe we have some conditional rendering with the ternary and it's not returning anything. So nothing may show up, but the component is mounted on the DOM. And it usually does mean that it's rendered, right? And remember, that's what happens in main JSX when we mount app on that root div. So this test is testing, and thank you, Brandon. This test is testing that this component exists. And we see that Cypress gives us this mount command that must do something pretty similar to what main.jsx does when app is mounted. And then one moment. And then we see here, we're getting some sort of CSS ID or class. So Cypress has added some stuff to the actual HTML so we can interact with it, just like we would do document.getElement by ID, and we can check what the text is in this component. Len, yes, sir.
So when you say mount, I go back. I'm just thinking. I want to make sure that I'm thinking of this in an okay way. To like when we had ISOs, when like we were moving away from CDs and we were going into like all digital, there was a point where we had ISOs and you would mount the ISO into your virtual drive. Is it similar, but you're mounting this component, this widget, this button, this function onto the DOM?
Yeah, pretty much.
Thank you.
Yeah, totally. And let's see actually if Stack Overflow can help me with a better answer. I think this is pretty much it. Because there's also React's virtual DOM, right? That JavaScript program that's using like JavaScript objects and arrays to have its simulation of the DOM. And when a React component is mounted, it also needs to be added to the virtual DOM. So I think they say it pretty well here. And you hit the nail on the head. It's like when you mount a drive, the process of creating instances in DOM nodes corresponding to React components and inserting them into the DOM is called mounting. Right, rendering is actually having it show up on the screen. And the same way, if I set display none to an HTML element, that element still exists in the DOM, but it's not rendered, right? So that's the difference between rendering and mounting. And let me dump this link in the chat. And if someone can cross-post it, I would appreciate it. And I do apologize. I do want to move on so we can stay focused on Cypress, but I'd be happy to dig into that a bit more after the lecture. So we can see here already that like this is one kind of test we can write. Has a component been mounted? Does it exist on the DOM? I can also write a test where I'm passing in some data as a prop, and I can test that my component is doing what it should with the prop, and that it actually renders on the screen the value that I want it to. And then finally here, something really interesting happens. And this is very much like Monkey Patch, right? Monkey Patch kind of hooked in and simulated the command line, right? It fed our program what it expected. The idea of a test spy is a similar concept. I have some sort of user interface event, like I click on a button and that fires like a DOM event, or I type into an input field and that fires an on change event, or there's a form submit DOM event. Well, how do I know that that's happening? I have to inject, I have to, kind of like slip some sort of monitoring tool into my component so it can see what's going on inside. So I don't actually so here I pass in what's called a spy, and it watches what happens here for this on change event, and we can just see that it was called. So here we click on something, we actually tell the browser to click on something, and we can see that indeed the thing was clicked. And I just want to see if folks have any questions about Cypress before we move on. And we're going to be doing a lot more with Cypress, so more so about kind of what we're looking at the moment. Okay, awesome. So there's another JavaScript testing framework. It's called Puppeteer. We're not going to be using it. And in fact, Cypress uses Puppeteer, but we're going to briefly look at it just to see like the difference between the two. And excuse me, I just had to pull up my notes. So if we go here to the Puppeteer getting started page, there's a lot more code here. There's a lot more stuff going on. I need to write some sort of async function. So Puppeteer does something really interesting. It's called a headless browser. And what that is imagine the Chrome browser. Now take away the user interface, the GUI, so that there literally is no browser window, but you could still run the browser program from the command line and do something like maybe using JavaScript, give it a command, go to this URL. And you can actually do that. And that's called a headless browser, right? And it's like we can use the browser program, we just get rid of the graphic user interface. And you can imagine how that might be really useful for writing end-to-end tests for like React apps for front-end stuff. And that's what Puppeteer does. It uses Chrome as a headless browser. So we launch our headless browser. We have to wait till the page loads. We have to navigate to a URL. We have to tell the browser what the screen size is. We have to like type into a search box. We have to tell it to wait once we search for something for the results page to load. And you can see there's just a lot more code and a lot more work here to do this. So on the one hand, Puppeteer is very powerful and maybe gives us more control, but it's more effort and it's more low level. Cypress is more high level. We don't have to write as much code, and Cypress actually uses Puppeteer under the hood. So that's Cypress and Puppeteer and sort of the trade-offs. Like if I needed to do something really fancy, maybe I need to use Puppeteer. But we can get awfully far with Cypress. In fact, if we hop over here to a Cypress one, we talk a little bit about Puppeteer in there, but that's the main difference. And like if I needed to like build Cypress, I could use Puppeteer. So Cypress is a really good starting point, and Cypress also uses a headless browser. So let's go ahead and let's like install Cypress and start using it and start looking at some code so we can make this stuff real. And I do have to go ahead and create a Vite project, so I'm going to do that now very quickly. And I'm going to make a React project. It's going to be JavaScript. I'm going to navigate in. I'm going to run npm install. And bear with me one moment as the installs happen. And let's run npm run dev just to make sure everything works. Everything works. All is well in the world. I'm going to leave the default stuff here this time, actually, because we can use it to help us write some Cypress tests. So I'm not going to rip out the default stuff we see here like we normally do. Let's go ahead and install Cypress. So I'm going to run npm install Cypress --save-dev. And does anyone remember what does this --save-dev flag do for the npm install command? Len, yes, sir.
It puts it into the dev environment so that when you actually publish it out in the wild, it doesn't go in with it. That's how I think about it.
Yeah, exactly. And it's even simpler. When in Cypress is installed, it's not going here under dependencies and package.json. It's going here under dev dependencies. And then exactly like you're saying, once we want to say like install or run or build our React application that's actually going on a website, we'll learn later how to tell it to ignore the dev dependencies, because the user doesn't need Cypress. Only the developers need Cypress. So these are just development dependencies. And let me go ahead and exit the full screen here, because once I open up Cypress, it is going to open up a new window. So let me just exit my full screen. And let me hop over here and exit my full screen as well. Okay, beautiful. So to open Cypress, we're going to use the command npx that executes a node module. And we'll see in a moment, we'll actually set up an npm script in package.json. But just to straight up run Cypress once it's installed, I can run npx Cypress open. And hopefully my Mac is not going to do anything silly. But we see a lot of interesting things happening here on the command line. A verification step, opening Cypress. It's telling me that DevTools is listening on this port and something. And what you all can't see, but you will now as I drag it over to my other monitor window, is this window popped up. And so Cypress has a nice GUI that is what we'll use most of the time when testing. And we can tell it if we want to do some end-to-end testing or some component testing. And we're going to want to do end-to-end testing most of the time. So I'll click here. And it has just added, it looks like some files for me, a Cypress config.js file. And we're going to look at that in just a moment. And most of these we don't have to worry about so much. We're going to have to tell Cypress what browser we want to use. So the default is Chrome. If you are using Linux, you may need to use Chromium. Electron is basically Chrome running on the desktop. It's a browser, but Slack is built in Electron. Electron lets you use HTML, CSS, and JavaScript and like React.JS to build desktop applications. So it's another browser, essentially. You can also use Electron if you want. If you're on a Mac, I recommend using Chrome. I need to check for WSL folks. You may need to use Electron. I'm not certain. WSL, I think, may also prompt you to install 1 or 2 additional things. And I will share the link and the commands for that after the lecture. And it should be just a one-step operation. So we'll flesh this out in a minute, but just to see what we get. And in fact, we don't get much here at all because we don't have any tests yet. So this is where we're going to see tests, and we'll actually see in the browser Cypress run the tests for us. So let me go ahead and just close this out. And we see here, Cypress says, hey, we closed. And yes, indeed, you did, because I closed you. So let's set up some Cypress config and write a test or two so we can see Cypress in action. And let me just go ahead and give us more space. And then when we're done, we'll circle back and bring back the browser. So now here in my project, and I'll clear this stuff to get it out of the way. So here's my project directory, source and everything that we're used to. A Cypress directory has been created. And this is where our tests will go. We're not going to really need to use fixtures. If we wanted to put sort of mock or sample data in here, we could, but we're not going to have to worry about that right now. Downloads, we don't have to worry about. Cypress can actually record videos of the browser running the tests, and we can configure it whether we want to do it or not. Cypress.config.js is where we need to add a couple things. And what we see in here looks pretty similar to what we saw with Vite config.js. We import something from the Cypress package, a function named define config, very well named, that will help define our Cypress configuration. We are passing an object into that function with all of the configuration that we wanted to have. And then we're exporting that configuration. So we are creating like a Cypress configuration that Cypress will use. And this JavaScript object right here is how we configure Cypress. And if we wanted to do component testing, you know, we would add component right here and put stuff. We're not going to worry too much about that. We're going to focus on end-to-end testing. So there's a couple things that we need to add here, so that Cypress knows what to do. I'm honestly not 100% certain off the top of my head what setup node events is doing. VS Code says it's related to handling Cypress plugins. The golden rule sort of with these kinds of config files that are semi-auto-generated is if you don't need to touch it, don't touch it. So I'm just going to leave that as is. And some bits that I do want to add are, and let me make sure I'm doing this in the right spot, because I want to add it inside this end-to-end object, is we need to add a property named base URL, because we are going to actually have to run the Vite dev server. So Cypress has, you know, our React app in a URL that it can interact with. And we need to tell it what URL to go to find our React app. So it's going to be HTTP localhost 5173, which is the same port that our React app is hosted on. So support files, if there's certain things sometimes we might want to do before a test runs, if we need to load some data or something else, that would be a support file. I don't know a ton about it, to be honest, and we don't have to worry about it right now. It's the kind of thing where if I needed to use it, I would Google it, but we don't. We also need to tell Cypress how wide the browser should be. So we're going to have to set viewport width and note the really nice auto completion that we get here. And let's set it to be 1024 pixels. I just give it the number, the integer in pixels. And let's set the viewport height as well. And let's set that to be 768. And that's a pretty standard viewport size. And Cypress can actually record a video of the tests, which can be really useful. So you can watch the video and see, you know, what happened. And kind of like Erica was saying, maybe the product team does actually use that. Though what the video is usually used for is like to make sure all the colors and the CSS styling look exactly right. It eats up space if we have all these videos being recorded, and I don't need it right now, so we're going to set video to false. And that should be everything we need with the Cypress config to get started. What we're also going to do is we're going to add some scripts to package.json. Because I want to make it easier to run these Cypress tests. And best practice with JavaScript programming is now that we're using NPM, any of the commands that someone needs to use for this project, we probably want it in an NPM script. In fact, you definitely want it in an NPM script unless you know for a very specific reason that you don't. So we want someone to be able to run an NPM script to run the tests. So this stuff is not in alphabetical order. I do like stuff in alphabetical order. So I'm going to do that. And now we can put the Cypress stuff here. You'll often see a naming convention, and excuse me for just a moment. Thank you. I did grab a sip of water. You'll often see a naming convention with NPM scripts where I might have, and I'm getting the red squiggly because I forgot my semicolon. I might have multiple related scripts. And here's the command we just did a moment ago, but plus a little extra. So if I want to just run a Cypress test from the command line, I can, and we'll see how to do that in a minute. And this is just a naming convention. So as a programmer, you know, as another developer who's using this, it's easier for me to remember all the Cypress commands. They all start with CY semicolon, and this is really just for us developers. So this is the command that we ran before that opens up Cypress and gives us the GUI. This lets us run an individual Cypress test from the command line without a GUI. Let's go ahead and write a Cypress test and see this in action. And I've been talking a bit, so I just want to check in with folks and see how people are doing and if folks have any questions. Chris, yes, sir.
So we have to manually write that in the scripts. Like we can't just how we do in the terminal, just install whatever and it will be put into scripts. We have to just write it in.
Correct.
Okay.
Yeah. And then what I can do is I can do npm run side open. And this actually ends up being a plus because this is also documentation. Like I like knowing that I can go to package.json and look at scripts and see all the commands I need because I'm not good at remembering stuff. But yeah, we have to manually add this, and we also have to manually make those modifications to the Cypress config file. Let's go ahead and write a test. And let me quickly talk about the structure of where these tests should live. So the tests need to live in the Cypress directory. And as you've noticed, Cypress, kind of categorizes end-to-end tests separately from component tests. So we need a directory named E2E for end-to-end. And I need to name the test a certain way. And it's going to be the name of whatever my test is. In this case, it's just going to be my first test. .cy.jsx. Right. I'm actually not sure if maybe Cypress does just fine with this, or it might break. I'm not certain, but this is better anyway, because now whenever another developer is looking at this, it's so easy to see, okay, this is a Cypress test file. And let me close out a couple of the things we don't need just to reduce clutter a little bit. All right, and let's write a test and then we can run it. So with unit testing, often the way you'll start is with what's called a describe block, where we're going to put maybe a couple related tests inside here, but I'm going to describe what these tests are for. And so Cypress will import this for us when it runs the test. This is a function. It takes two arguments. The first is a string that describes the test. The second is an arrow function that Cypress will execute. And this arrow function is really basically a container for our tests. Because inside here, I'm going to write an it block. And VS Code is giving me some terrible autocomplete there. I can probably do. I'm not sure if importing describe from Cypress will work. I will follow up about fixing the red squigglies. I'm sure there's a way to do it. So I will follow up about that. So I do hate the red squigglies. Inside the describe block, we write an it block, and this is the actual test. And I apologize, I was jumping around a bit, folks. So let me write the correct test and not the other test that I was about to write. And we're just going to visit the app and asserts title exists. And just like the describe block, the first argument to the it function is a string that says what the test is. The second is an arrow function, and it's going to hold the contents of the test. And this way, I could have multiple if blocks, some other test. And then I could, and this is how I can organize my tests. But let's actually write a test. So we saw, and I'm so sorry. I will hunt down what's giving me these really terrible autocomplete suggestions. We saw that Cypress lets us do side.visit. And let's actually pull up the Cypress docs while we do this. And let's go to the reference. And we can sort of see all the different things that we can do in here. I apologize. The reference, I will dig around to see if there's like one good spot. Here we go, the API. So that's what you want. Sometimes they call it the reference. Sometimes they call it the API. Here's all the Cypress commands, and I'll dump this link in the chat now. And if someone can cross-post it from Zoom to Slack, I would appreciate it. And so there's different things we can do with Cypress, right? There's queries to see, to grab maybe an HTML element, to filter, to find something, to compare stuff. There's assertions, something should exist. There's actions, such as visiting a website. And so somewhere around here has to be visit. And it looks like it's way down under other commands, which is honestly a little counterintuitive. I guess they don't consider it an action. But here we can see the command, they give us the syntax, the URL. If there's options we need to give it, we can do it here. And you can see there's a whole range of different commands we can use. So this is super useful, and we had to dig a little bit, but this is actually really nicely documented. So let's continue writing our test. So we're gonna visit the root URL of our website, which is gonna be localhost port 5473. Actually, I should probably, let's see, HTTP localhost 5173. We'll make sure that that works. And let me make sure I have my port right. And now, we have to know what we're testing. I just want to test that this H1 exists. So I'm going to do sci.get H1 should, right, an assertion, contain, and then the text of what should be in there, which is Vite plus React. And this is where like having those Cypress docs out as I write this is really useful, because here's the breakdown of that should assertion and how to use it. And note that we can do really nice things like be visible, be empty, or like I'm doing here, should contain. We can also check for equality. So that really should be all I need for the test. Fingers crossed. This one is empty and does nothing, so I'm going to get rid of it. Let's run Cypress and see how this works. And we'll see if I need to maybe change that URL. So over here, we've got my first spec. I did see an error message. Yeah, here we go. And I forgot to do the thing I mentioned earlier that it's important to do. So this is actually a really good teaching moment. If my web app isn't running and hosted on a server, Cypress can't tell the browser to go there, or it can, but it's not going to get anything back. So I always have to make sure I have my Vite dev server running when I run my Cypress tests. And the way I like to do it is I'll have two things open here, and I'll just name one like dev server. And I'll try to make sure that this shell session is the one that I always have the Vite dev server running in. So let me go ahead and navigate into here and do npm run dev. And so if you see this warning, that's what it means. Let's try again with our fingers crossed that this will work. And I'm not sure if Cypress just got unhappy. There we go. And so now we can watch a test run. Right? So end-to-end tests take a little more effort, but now we can see, right, all the different tests that we have. And I can go ahead and run the test. We can see Cypress here driving the browser, and I can actually click through each part of the test. Here it visits there, it grabs the H1, it asserts that the H1 is correct. Right, so that's what Cypress can do, which is super cool. And let's go ahead and add another Cypress test just for fun. Maybe let's assert that the count is 0, that this button says what it should. And maybe we want to name this describe block to assert initial page load displays correct information. So we'll have a separate test, because if something goes wrong with this one, I don't want it to break the next test. And let's get a button and assert that it should contain count as 0. And now I might have to close and reopen Cypress. So let's go ahead and just exit it and open it up again. And we'll give Cypress just a moment. Oh, and I apologize. I got a little confused, folks. For some reason, I had a brain freeze. I was expecting a second file, but we put the two tests in the same file. And I don't think we had to exit and reopen Cypress. So you should not have to do that. Though I'm not seeing my other assertion in here, which I am a little confused by. So I think, so there's something I'm not doing right. Oh, there it is. I apologize. Again, my apologies. I just got a bit confused. To reiterate, this is the describe block message. And then inside here, each of these are individual test assertions. And we can see that both of these pass. And just for fun, let's modify a test so it fails. And then I think that'll be a good pausing point. And so I caused this test to fail on purpose, but this is what a failure looks like. And we can see here that we get some really useful feedback. We see exactly where in the test the failure occurs. We could print stuff to console if we wanted. By the way, since this is running an actual instance of the browser, this is indeed a website that I can interact with and click on and do stuff, including if I want to, opening up the inspector. So if I say want to go back to a previous point in time, I can have DevTools to look at what's going on with my application, which is really cool. So in a nutshell, that's Cypress. I think you can kind of see like how useful and powerful it can be. And how great it can be to have these tests. You can also see, you know, what some of the trade-offs of end-to-end testing are. But honestly, Cypress is pretty cool. So I've been going on for a bit, so this is a good time to pause and check in and see what questions folks have or what's on people's minds. Eric, yes, sir.
I was curious when it comes to the assessment next week, is there any like are there tests that exist for kind of the way your app looks? So like asserting that there's styles applied essentially, or is it really just going to be like testing for functionality, ensuring that things exist on the page and they work as expected? It could just be styleless essentially.
It is going to be a bit of everything. I don't think there's a super heavy focus on CSS styles, but I think there is some. I'd have to check, to be honest. But like I don't think we require you to use Bootstrap, for example, on the assessment, and I don't think we require you to use Tailwind. That said, everything we're covering in React is related to the assessment, and it very well could be that you will have to use certain CSS classes with names that are specified in spec as part of the assessment. And if you did, obviously we would tell you. You know, you can also use Cypress to click on buttons and do stuff, right? And this really belongs in a separate describe block and maybe in a separate file, but just to demonstrate, I wanted to just code it up real quick. And indeed, you can see I don't need to refresh Cypress. And this test goes there, it finds the button, it clicks it. Now it clicks it. And note that count changed to 1, and we assert that it changed to 1, right? And that's a perfect example of an end-to-end test. I'm not testing how you designed the React component and the state. I don't care about that. I care about the behavior that the user does and what the user sees as program output. Does that help answer your question, Eric?
Yep, no, it does.
Awesome. Yeah, good question. What else is on people's minds? Okay, how are we feeling about Cypress? Are we feeling like this is kind of cool, kind of a lot? Where are we at? Brandon, yes, sir.
Seems like quite a bit of setup, but once it's set up, it's pretty straightforward.
Yeah, I would agree with that. I think Cypress has done a really good job of making end-to-end testing a lot easier than it used to be. Let's say that for sure. There is a little bit of setup, but the good news is we actually give you pretty straightforward steps on how to do that. And it is a lot of fun to be able to do this and see your app do this and work. And you could see too how if you get in the habit of writing tests as you go, you know, like if I was writing code, I probably don't need to check that the H1 says what it does, but writing a test, the test that like when I click on the button, it does what it does, that's kind of nice. Because then if I do refactor my code because I want to make it better and I accidentally introduce an error, my tests will tell me. Let's go ahead and let's just take a quick look at the assignments today. And then we have the retro in a bit, so maybe we'll just break a bit early. So we do have another reading assignment in this book, React.JS Foundations. If you haven't been reading it, I do recommend it. It's quite good. Although scrolling through the table of contents is not very useful. So the assignments today are pretty open-ended. We want you to create a React project that uses Cypress and gets familiar with it. And actually, there's one more Cypress command I do need to show folks that will be pretty quick. And then this other one is also pretty open-ended. Try to work on refactoring something to use more of use state and use hooks, to use more components, to add some styling and to add a test suite, right? So either be writing something new and using Cypress, or if you're refactoring, start with Cypress, write the Cypress tests, maybe if your React program you've already written, and then do some refactoring of it, right? And you can sort of feel the advantage of the test harness and test-driven development. And so the one thing I did want to show with Cypress is how to run Cypress tests without the GUI. And we wrote two scripts here, remember? Cyrun. So I can give Cyrun the name of the test that I want it to run, and it will run it on the command line. So I can do npm run Cyrun, and let me make sure I get this right. And I need to give it the full path, which is what I thought I might get wrong, which I could tell because it tells me, hey, I'm looking for this thing in this directory, and that's obviously not it. So let's do this one more time. npm run Cyrun, Cypress /e2e/ my first test.cy.jsx. There we go. And just like with running PyTest tests on the command line, we see our describe block, our individual it blocks, what's passing, what's failing. Note the browser Electron, which I mentioned earlier. Slack is written in Electron. It's headless, so there's no GUI. And we can see the browser in the version of Node that we're using. Eric, yes, sir.
Didn't have my hand up.
Oh, okay. Erica, yes.
I know that you can see this in the other like window, but what about like a failure in the terminal? Like, does it have? Yeah.
Yeah, absolutely. The other window is much nicer, as you can imagine. The GUI is really, really nice. The fact that you can click through each step and use dev tools. Because the reality is, if I have to debug some React code, I'm almost definitely going to have to open up dev tools for either the console or the inspector, or I really like that React dev tools extension. But we will get a failure message here, which will happen in just a minute. And you can tell that this takes longer, right? Because it's actually running the browser. So a couple interesting things happen. Really good question, Erica. We see that the test fails. We see one failing. We see an assertion error. We see a little bit of a message, timeout. We also see that it's created a screenshot, right? Because Cypress is for testing user interfaces. And because VS Code is amazing and we can open images in it, we can open up the screenshot and we see, in fact, the screenshot of the GUI. So, and if we told it to record videos, it would also have recorded a video, but that just takes more time. So I do recommend, like, for anything serious or non-trivial, you're gonna probably be wanting to use the GUI because there's not a lot you can do with this to like dig in and debug. But this is there, and that's what you get with it as well. And if you did want a video in Cypress config.js, you would just change video to true. The test would take longer to run, but you would also get a video of it. Did that answer your question?
Yeah, absolutely.
Awesome. And great question. Len, and I see you saw in the chat, I may have misunderstood your question there.
I see now. No, you were explaining to us about the assessment, and you give us the spec for the assessment, and we can choose the tool implementation, because I think you said it after I posted that, because you don't care how, you just care that it does. I'm oversimplifying this to try and speed things up.
Yeah, more or less correct. Yes. Murad, yes, sir. Oh, I think you might be muted. Oh, I think you might be muted, Murad. Oh, I'll ask you can you unmute? Or I'll follow up with you after class. Hold on, guys. Dustin and Murad, I'll just follow up with you guys after the lecture. Yeah, because we're about to break now because we've got retro in 9 minutes. Let me go ahead and